Hi, my name is Suraj Khurana and I will be demonstrating my multi-tenant cloud application of UML parser. This is a joint collaboration by students of cmpe 202 and cmpe 281. Students from cmpe 202 who are a part of this project are Sparsh Sidhana, Siddharth Kore, Netra and Nivedita Nadkarni. Students of cmpe 202 are responsible for creating a UML parser, and I am responsible for hosting this application on AWS web server, AWS cloud. I am also a student of cmpe 202, hence I am also a tenant of myself. Let us take a look at the AWS configuration. Initially, let's take a look at the EC2 instances that are running. For every tenant, I have one instance running with a suffix of tenant. Initially, I spawned two front ends behind a load balancer, front end and front end 2. As you can see, this process is terminated because of the auto scaling policy of non-usage, which we'll come to in a bit. Let's look at the load balancer. The load balancer forwards all requests, TCP HTTP requests, to port 8080 of the instances. As you can see, I have used the load balancer DNS and it is automatically routing to an EC2 instance where my web app is hosted. Configurations that I have set on it: health checks, okay. Next, let's look at the autoscaling group. My front end is designed to autoscale itself when there is heavy load. It will spawn more instances, and when there is less load, it will decrease instances. The minimum that I have set to is 1 and the maximum I have set to is 3. Maximum of instances that can be spawned I've set to 3. The desired is 1. Let's look at the scaling policy. So the scaling policy says that remove an instance if the CPU utilization is less than 20 for 300 seconds. Similarly, increase the group size or spawn up a new machine when the CPU utilization is more than 40 for 300 seconds. Hence, you could see that one of my front ends which I had spawned earlier got killed because of non-utilization. The launch configuration that I'm using for this is an AMI that I call front end. I use this AMI in my launch configuration. Our application also uses Amazon RDS for storing data like the grades and login information. Let me show you a quick demo of our application. As you can see, I put in the wrong credentials and it prompted me that you put in the wrong credentials. Since it's a UML parser, we'll be uploading a set of source files, source Java files. We call it test4.zip. And when we submit it on the back end, it is calling the UML parser jar and generating an output, and my web app is only getting the image of the output and displaying it. So as you can see, this has created a UML from the source files class diagram. As you can see here, there are a few attributes that I can enter. Say I enter a comment I do a submit. These values go and are saved in Amazon RDS. Let me quickly do this process for all the tenants. If you notice, now we have fewer fields, and that is because these fields are dynamically populated based on the multi-tenant model that we have implemented on our database, which I will get to you in a bit. Again, you can see the fields changed. So these fields are populated dynamically from the DB. We have a multi-tenant database which can, as the name suggests, it can act as a database for many tenants. And the way we implement that is by using a shared MySQL tables. Let me get back to that in some time. Again, you can see these. Let's enter the grade A on a scale of 10. Submit. Finally, I run my jar. Okay, so that was a quick demo of all the UML parsers for all my tenants. Now we entered the grades for all of these tenants, and they have been saved in our DB. Now let us look how they have been saved and how am I implementing a multi-tenant architecture with only 3 tables. First, use the schema that I'm using to save all my files. save all my grades. I'm sorry. Alright, and then let me show all the tables in this database. Sorry. So as you can see, we have 4 tables. One is used only for login, and the others are tenant data, tenant fields, and tenant table. So let me show you how those tables look like. Okay, so as you can see, tenant table just basically contains information of all the tenants that I have in the database. Now this table contains all the fields for different tenants. So as you can see, for tenant ID 1 there's a field named comment. For tenant ID 1 again there's something called as completion. For tenant ID 1 there's grade, and for tenant ID 1 there is scale. We also have something called as field column. This is where the actual data, or which column the data is actually saved in another table called as tenant data. So as you can see, this table holds the different attributes that you want to store for different tenants. So for tenant 2, I just want to save grade and scale, and they are saved in column 2 and column 1. For tenant 3, I just want completion. For tenant 4, I want completion and grade. For tenant 5, I want completion, grade, and scale. Now let's see how the data looks in tenant data. Alright, so this is, you can say, a master data table which holds the data of all the tenants. However, to make sense of this data, you need the other table, tenant fields, and by having a join on them, you can actually get what the meaning of every data is. I hope you can understand what the mapping I was talking about in tenant fields. And this is how I have implemented a multi-tenant database in MySQL. With just these three tables, I can implement as many users as I want, and I don't have to create a different table for every different user. Okay, all right, and all right, thank you.